And
right?
yes, so x has to be equal to 10 here. So 9 plus 10 has to be equal to 9 plus 10. So we could extend that into the next thing, is if I have exponents and I have 2 to the x is equal to 2 to the fifth, obviously, what does x have to be equal to here? If they're going to be the same on the left and the right.
5.
5, right? And then here, x has to be equal to 10, right? And obviously, last one is x has to be equal to 1/2. Okay? Okay, so now we're going to go ahead and look at the next, look at this table here. Just take a quick look at that. Okay, sorry about that. So last week you also had a table of common powers here, and so this is just listed for you. Here are the powers of 2. 2 squared is 4. 2 to the third is 2 times 2 times 2, that's 8. 2 to the fourth is 16. 2 to the fifth is 32, right? Here, 3 squared is 9. 3 to the third is 27, and so on. And then here are the powers of 4, and here are the powers of 5. So what we're going to be doing is we're going to be solving exponential equations. So this is new for basically all of you, I think. So if we look here, okay, Waldo, you just joined, right?
Yeah.
Look, the top is very simple. Look what I have here. If I have 2 plus 3, what does x have to equal?
3.
3, because the equations have to be the same left and right, right?
Mm-hmm.
3 minus 1 has to equal to 3 minus 1. 9 plus 10 has to equal to 9 plus 10.
Yeah.
And then the next row, same thing happens when you have exponents. If I have 2 to the x equals 2 to the fifth, obviously x has to equal
5.
right? Okay.
Mm-hmm.
So that's all we kind of done so far. And this is kind of a table of powers that you've kind of seen before on one of the previous assignments. It
Mm-hmm.
has the powers of 2, the powers of 3, powers of 4, and powers of 5. Okay. So now let's go into solving the following equations by using the method of common bases. Now, I know that you could probably see number 1 and know what the answer is because I just told it to you up here. You already know that the answer here is going to be 4 because 2 to the fourth is 16. However, we're going to practice with these simple problems a method of common bases. Because even though you don't really need to do them here, we need to get used to this new method. So I want everyone to kind of understand what this method is. So we'll take it step by step.
Mister,
Yeah.
you're going to be posting this?
Yes.
Okay.
Okay. But please follow along right now. Okay. 2 to the x. So I know that 2 to the x is equal to 16. So let's look up here. Right here. I know that 2 to the fourth is equal to 16. So the method of common bases means this. We need to get both the left side and the right side to have the same base. So the way this is going to look like is I know that 16 is equal to 2 to the fourth. So I am going to change this equation to look like this. 2 to the x is equal to 2 to the fourth. Yeah, I see that, Alyssa. So you see that Now the equation has the same base. That's the whole idea of this lesson. You are turning this equation so that the two things on the left side and the right side will have the same base. And here you have a base of 2. So 2 to the 4th is 16. And then now we're going to go back to up here when if you have the same base, the exponents are equal, right? So my answer here is x is equal to 4. I know that a lot of you could, and I talked about it, you could see what the answers for these questions are right away. But we're practicing a new thing called the method of common bases. So we have to go through this step, okay? Because the problems are not going to be just like this. So we need to get used to rewriting the equation like this.
Mr.
Yeah. Waldo, you had a question?
My laptop is broken. Like, it doesn't let me put the equal. My laptop doesn't let me put the equal sign.
What about the equal sign?
It doesn't let me put it.
Oh, on yours? Are you using like,
Yeah.
what are you using? Are you using Kami? Are you using Classroom? What are you using?
Docs.
Oh, I don't know why it's not letting you put the equal sign. Did you put the insert equation?
The what?
Can you just take these notes on a separate sheet of paper for now?
Yeah.
Yeah. Okay. Because remember, you don't need to do the notes in, right? You just need to put in the classwork. Okay.
Mm-hmm.
Okay. So let's look at number 2. Right here, you see I have 3 to the x is equal to 27. So if you look up here, you know that 27 is 3 to the 3rd, right? So I am going to rewrite this equation so they both have a same base. And obviously I'm going to use a base of 3. So 3 to the x is equal to 3 to the 3rd because 27 is 3 to the 3rd. And then I get my answer here as x is equal to 3. Number 3, 16 is equal to 4 to the x. I see that 16 up here is equal to 4 squared. And then, so that means I could rewrite 16 as 4 squared. So this is going to be 4 squared is equal to 4 to the x. And then so now my answer here is 2 is equal to x. And then this last problem here, 125 is equal to 5 to the x. I just look up at our table and I could see right here that 125 is 5 to the 3rd. So I'm just going to rewrite this equation so they have the same base. So this is going to be 5 to the 3rd is equal to 5 to the x. And then so 3 is equal to x. So a couple of things that I want you to do now. I want you to do 5 through 8 on your own. Also, if you are taking notes on a separate sheet of paper, I'm going to be scrolling past this and you will probably need this table for later problems. So if you want to take a picture of it, now would be the time to do so. So you could use it for later problems, this table here. Okay, so I'll give you a couple of minutes to do 5 through 8 if you haven't done it already. I'm pretty sure some of you have already done it. But go ahead and take some time, and then in maybe a minute or two, we'll go over these questions. And once again, if you have a question, please ask or type it in the chat.
Mister, when are you gonna update the grades again?
Well, I put in the 2 assignments from last week. If you turned in any, oh yeah, because Tony, you turned in late assignments. I'll do that sometime. I don't know when. I'll let you know though. Okay. I should have more time this. Okay, so everyone, please work on 5 through 8.
Mister,
Yeah.
can you do the homework in the piece of paper?
Yes. I actually I told the class before you joined, Waldo. This homework assignment I want you to do on another sheet of paper, please. Unless you feel very comfortable with putting all this stuff into the assignment, I think a lot of you would find it faster to just write it out and do it.
Alright.
And take a picture and just attach it to the assignment. Okay.
Mm-hmm.
But if you feel very comfortable with either typing this in or using Cami to write it in, but I want to see all your steps. That's why.
Mm-hmm.
Okay, so now let's go over 5 through 8. So the first one is 3 to the x is 81. So if I look back at our table, I see that 81 is 3 to the 4th. So I'm just going to go ahead and rewrite this as 3 to the x is equal to 3 to the 4th. And then obviously the answer here is just going to be x is equal to 4. Number 6, I'm going to go ahead and look back at our table. 32 is 2 to the 5th. So I'm going to rewrite this as 2 to the x is equal to 2 to the 5th. And then so now that they have the same base, x is equal to 5. 25 and 5 to the x. Well, 25 right here is just 5 squared. So I'm going to rewrite this equation as 5 squared is equal to 5 to the x. And then so my answer here is 2 is equal to x. And then the last one, 64 is equal to 4 to the x. Right here, 64, and I forgot to put a 3 here, but 4 to the 3rd is 64. So I could rewrite this as 4 to the 3rd is equal to 4 to the x. And then so 3 is equal to x. So the whole idea here is you need to get both the left side and the right side to have the same base. Once you have the same base, you can just set the exponents equal to each other. So before we move on, does anyone have any questions on 5 through 8? Okay, so now let's go ahead and move on. So before we go into equations, we need to review something from last week. We need to review the rule of power to a power. Now, if you remember from last week, we had 2 different rules. We had 3 different rules, but I want to focus on 2 rules right now. So remember when we had something like x squared, oops, it's a 2, times x to the 3rd Let me write that down. Okay, so remember when you had something like x squared times x to the third? What do you do with the exponents here? Anyone? Add, right?
Yeah, you add them.
You add them. So this would be x to the fifth. Now, the one other rule that we had is if I had x squared and I took that to the third, now what's the rule here? What do you do with the exponents?
Distribute.
Yeah, so you distribute, you multiply, right? So
Yeah.
this would be x to the sixth, right? This here, this rule here is the one that we're going to focus on today. When you have a power taken to a power, you're just going to multiply. So if you go ahead and you look at 9 through 12, all of these questions are power to a power. So all I'm going to do here is just multiply the exponents. So if you look at number 9, and I have 2 to the 4 taken to the x power, and you just multiply the exponents, this is 2, and 4 times x is just 4x. Right? Number 10, 4 to the second to the 3x power, this is just going to be 4 to the 6x. 2 times 3x is 6x. Now, number 11, we really haven't done this yet, but because on last week's lesson, we never had two terms. But if I multiply the 3 times the 2x minus 4, just like Tony said, you have to distribute. So that means you have to distribute to both the 2x and to the negative 4. Sorry for that, those bad arches. But so that means this is going to be 3 to the 6x minus 12. Everyone see what I did there? I took the 3 and I multiplied it by the 2x to get 6x, and I multiplied it by the negative 4 to get negative 12. Okay. And so go ahead and do 12. So if I multiply the 2 into both terms, this will give me 5 to the negative 8x, and then 2 times 3 is 6. So I multiply the powers. Okay. So now we're going to go into more equations. Now the difference with 13 through 16, or for 13 through 15, is that some of our exponents have more than one term. That's why we needed to practice this. And look at number 13. Look at the two bases, 8 and 32. Now, 8, if I do 8 squared, that's already 64, right? So I cannot make 32 to have a base of 8 because I cannot multiply 8 times 8 and get 32. So what I need to do is I'm going to use the table here and find which of these bases I can use that have 8 and 32. Well, if we look here, I'm going to erase this now. I can see that 8 is 2 to the third and 32 is 2 to the 5th. So you see how they both have a base.
Do we add them or subtract them?
No, I'm going to show you what we're going to do here again. So don't do anything with the two things yet.
All right.
I do know that but everyone was able to find it in the table, right? 8 is 2 to the 3rd, and 32 is 2 to the 5th. So what I'm going to do is I'm just going to go ahead and rewrite that here so we don't have to refer back to the table. 2 to the 3rd is 8. Okay. And we also know that 2 to the 5th is 32. So what I am going to do is I'm going to rewrite this equation using these two facts. So I know here, oops, I know that 2 to the 3rd is 8. So what I'm going to do is I'm going to rewrite 8 as 2 to the 3rd. And then 8 is being taken to what power? The x power. So I still need to put the x on the outside. But what I just did there was I rewrote 8 using 2 to the 3rd. Now the right side, 32, I know is equal to 2 to the 5th. So why did I have to do that step? Because in order to solve these equations where the variable is the exponent, you need to get the two bases to be exactly the same. So you see here that this has a base of 2, this has a base of 2. And so now I can go ahead and solve this equation. So this is the big step in this whole process, to get from here to here. Everything else hereafter is just more arithmetic. But this is the big think process step here. So now we're just going to go ahead and do the same thing we did here. If I have power to a power, I just multiply the two powers. So this is 2 to the 3x is equal to 2 to the 5th. And then now, what can I do when I have the bases the same? You can just set the exponents equal to each other. So once you have that the two bases are exactly the same, 2 and 2, what I'm going to do now, I'm going to actually go here, is you just set the exponents equal to each other. So I'm going to have 3x is equal to 5. And now you have a basic equation to solve. And then so all I have to do here is just divide both sides by 3. This cancels. And then so my final answer here is x is equal to 5 over 3. So this is a brand new process to, I think, all of you, right? So we kind of have to go through this multiple times until we kind of get this. So once again, the whole idea is make the left side and the right side to have the same base. Then you just set the exponents equal to each other, and then you solve for the variable after that. So let's look at number 14. I have 125 to the 6th, and I have 25 to the 2x. So going back to our table, I think it's kind of obvious which powers we're going to use here. It's 125 and 25. So obviously I am going to use the powers of 5 here, right? 125 is 5 to the 3rd, and 25 is 5 squared, right? So just so that we are aware of where I'm, yeah.
Does it matter which one is being like powered to the x, or is it always the smaller one?
It doesn't matter. It could be the bigger or the smaller one. So Tony, look at 16. There's x's on,
Oh,
right?
it actually says which one is powered to the x.
Yeah. So you could have the x on either side, right? It doesn't matter
Uh-huh.
the smaller or the bigger. But once you see it as an exponent, you know you have to use this method, right? Okay, so I know from the table above, I know that 5 to the third is 125. And I also know that 5 squared is equal to 25, right? So what I'm going to do is I'm going to rewrite each of these, the left side and the right side, using the powers of 5, okay? So let's go ahead and do that right now. 125, I'm going to rewrite as 5 to the third, because that's what 125 is, but that's still being taken to the 6th power. So you see what I did here? 125 gets replaced by 5 to the third, and I'm still taking it to the 6th power. And then on the right side, 25 is going to get replaced with, 25 gets replaced with 5 squared. But I still take this to the 2x power, right? So what's the next step after this? Well, you need to go ahead and do the power of a power rule, the same thing we did in 9 to the 12. I just multiply the exponents. So this will become 5 to the 18, and this will become 5 to the 4x. Now, once you get the 5s to be the same base, you could just set the exponents equal to each other, right? Because if the bases are the same, the exponents have to be the same as well. So I'm going to continue it right here. 18 is equal to 4x. And then now that just becomes a simple equation to solve. I'm going to divide both sides by 4. This cancels. And so x is 18 over 4. But you could reduce this to 9 over 2. But if you leave 18 over 4 on a test or something, I won't mark it off. Or actually, I think this next test is multiple choice. So yeah, it's probably going to be the simplified form. Okay. Okay. Any questions on those two? Okay. So number 15 is more of the same, except now your exponent has 2 terms, but it doesn't really change much. So I have 9 and 27. So if I go back up to the table, and I look here, I see that 9 and 27 are both powers of 3. Okay. So right here, 9 and 27 are both powers of 3. So once again, I know that 3 squared is equal to 9. And I also know that 3 to the third is equal to 27. So I'm going to use those powers to rewrite this equation. I'm going to replace 9 with 3 squared. And it is going to be taken to the 2x plus 1 power. So once again, 9 gets replaced with 3 squared. I still keep the exponent exactly the same. Don't do anything with the exponent. And then 27, I'm going to rewrite as 3 to the third. Sorry, 3 to the third. Now, I know the next step is to multiply the exponents if you have power to a power. So this is why we practice distributing here, like number 11 and number 12. We need to distribute that 2 inside here. So this is going to be 3 to the 4x plus 2. And this is going to be equal to 3 to the third. So now that the bases are the same, we could set the exponents equal to each other. So this will be 4x plus 2 is equal to 3. So once again, once you get the bases to be the same and the exponents simplified, drop the bases and just have the exponents equal to each other. So now all I need to do is subtract 2 from both sides. It's a simple two-step equation now, right? Subtract 2, subtract 2. And then so now I get 4x is equal to 1. And then so all I do here is I divide both sides by 4. And then so I get a fraction here as my answer. So x is equal to 1 over 4.
Mister, do you need to put the 3 with it or no?
What 3? This 3?
From the base. From the base.
So here, once the bases are the same, you just move, you basically do this. Once the bases are the same, just take out the bases and make the exponents equal to each other.
Okay.
Okay?
Mhm.
Okay, last one I'm going to do with you, and then I'm going to have you try a couple on your own. 64 to the x is equal to 4 to the x plus 2. So now I just have variables on both sides, but it still applies the same thing. First thing I have to do is look for a common base here. So if I go back here, I already see 64 is a power of 4. So 4 is already a base. I don't need to change the 4. I just need to change 64 to be 4 to the third. There should be a 3 here. Okay. So I know that 64 is 4 to the third. So I'm changing 64 to 4 to the third. I still keep that exponent of x. I actually do not need to do anything to the right side because the base is already 4. Okay, and then now obviously before we set the two things equal to each other, make sure you distribute any powers that you have. So this will become 4 to the 3x is equal to 4 to the x plus 2. So once again, now that you have the bases the same, and then so like Waldo again, like we were talking about, you do not need to write the 4 anymore. Once you have the bases the same, you just set the exponents equal to each other.
Mm-hmm.
And then so this would be 3x is equal to x plus 2. And then so you go ahead and you just solve this like you normally would. Bring the x's to one side. Subtract x here. Subtract x. This cancels. And so I end up with 2x is equal to 2. And then I just divide both sides by 2. And then so my final answer here is x is equal to 1. So once again, the whole idea here is getting to this first step. So what I want you guys to do before we go is I want you to try some of these on your own. And then I'm going to go over them, but I want you to at least try them before you do the classwork to make sure you understand it. Yes, Rodney. The first step is to always get the same base.
Mister, in the classroom for number 7 for 49, it doesn't have the
It doesn't, but think about it. What's 7 squared?
what?
What is 7 to the second power?
49.
Yeah. So you're just going to use 7 squared.
All right.
Mister, how many more weeks of school do we have left?
It's the same. If I look at my calendar correctly,
I'm so done with this, mister.
it seems like it's 5 weeks plus the finals week.
So wait, we still have finals?
I don't know. I think the Birmingham School Board, I think, is meeting on a weekend, and they have to decide on everything. See how we haven't really given you like a how all the grades are gonna work and everything. That's because they still have to decide.
Okay. Wait, mister, I have a question.
Yeah.
Why, like, does LUSD, like, if you, whatever you left the school with, like, whatever grade you left with, you can't get anything below that. But why does Birmingham, like,
So they actually surveyed a bunch of teachers, and there's a lot of teachers who actually support that, not giving you a
I
lower.
hope that was not you, mister.
Right.
Well,
Because
Did you say yes?
that'd be like,
that you can't get a lower grade
Tony!
than March 13th.
Yeah.
Why? Why don't you want that?
Because it doesn't make sense. Online is not easy. Like, not easy at all. Like this, okay, math is like my
online
teacher
is boring. I hate
assignment.
online class.
No, okay, hold on. I'm gonna mute you. So what that means is you can't get anything lower than before we did online work. Because we know that a lot of you struggle with online work. Some of you might not even have access to online stuff, right? So whatever grade, let's say you had a B going into online class, you basically, B is the lowest grade that you can get. You can't get anything lower than that, right? Obviously, those of you that had an F going into the online learning, that doesn't really affect you because it's an F, right? But if you had like an A, a C, we can't give you anything lower than that.
So, but Birmingham does support it then.
Well, a lot of teachers did support it, but I don't know. We have to see what the administration and the school board says. Okay.
So,
Okay.
Mister,
Well, no, Emily, I don't, not yet. Don't think of it like that yet because it hasn't been finalized and stuff like that.
so
So-
basically, if that happened and you had an A,
Yeah.
like Emily, you could literally not do any work and still pass the class.
Okay, so here's the thing.
We're quoting you, mister.
Yeah. Well, if that gets decided on, then yes. However, I assume that most A students will keep doing the work because they are going to be going into the next class and they need this information, right?
I already had an F, so nothing changes for me.
Okay. Yeah. Um,
Right. I have an F.
okay.
It's fixed by the time you put the grades in the.
Yeah. Okay. So let's get through these examples first. Okay.
This is just 2 classes, mister, of stuff I have to do. Just 2 classes.
Yeah. Okay. So let's go through these examples and then you could ask any questions after. Okay. Whoops.
All right.
Let me mute you. Okay. So here's 17. 25 is the same thing as 5 squared, right? And then 625 is 5 to the 4th. So this will become 5 to the 2x is equal to 5 to the 4th. And then hopefully you got that 2x is equal to 4. if you divide both sides by 2, your final answer here should be x is equal to 2. Okay. So hopefully you guys got that one. That wasn't too bad if you look at the table and do everything with it. Now let's look at number 18. So 18, I have 16 and 8. These would be powers of 2, right? So 16 is 2 to the 4th. Sorry. 16 is 2 to the 4th, and 8 is 2 to the 3rd. So I'm going to rewrite this equation as 2 to the 4th. But I still have to keep this power of 2 here is equal to 2 to the 3rd. And this is going to be taken to the 3x power. And then now, if I multiply the exponents, this is just 2 to the 8 is equal to 2 to the 9x. So once the bases are the same, we are going to put 8 is equal to 9x. And then from here, it just becomes a simple math equation. I divide both sides by 9. That cancels. And then so my final answer here is just x is equal to 8 over 9. And number 19, 3 to the 2x minus 5 is equal to 9. Well, 3 is already a base, so I don't need to change the 3. I'm just going to change 9 to 3 squared. So this will become 3 to the 2x minus 5 is equal to 3 squared. And then so now what I do here is, since they have the same base, I'm just going to set the exponents equal to each other. So this would just be 2x minus 5 is equal to 2. And now I just solve this equation here. Add 5. Add 5. And so I get 2x is equal to 7. Divide both sides by 2. And then so x is equal to 7 over 2. And then now for the very last question. 4 and 8 are powers of 2. Here's where some people might get confused. They think 4 times 2 is 8, so they're going to change 8 to 4 squared. Do not do that, please. I know that's a common mistake, and I was seeing that last week on the first assignment. 4 times 2 is 8, but we're not doing multiplication here, we're doing powers. So 4 squared is 16, so you cannot change 8 to 4 squared. What you have to do is you have to go back and see that I'm going to be using the base of 2, because 2 squared is 4 and 2 to the 3rd is 8. So I have to use where they have the same base, right? And I have to use exponents, right? So this would be 2 squared and this is taken to the 2x plus 1. And then 8 is 2 to the 3rd, and I will be taken to the x power. And then so now let's just do the last couple of steps here. Multiply the exponents. So this would be 2 to the 4x plus 2. is equal to 2 to the 3x. And then now all you have to do here is once the bases are the same, you just set the exponents equal to each other. 4x plus 2 is equal to 3x. And then once again, you just solve this basic equation. You need to get all the x's on one side. So I'm going to subtract 4x from both sides. And then this cancels here. And so I'm just left with 2 is equal to 3x minus 4x is just negative x. We want x, we don't want negative x, so I just divide both sides by -1. And so -2 is equal to x. Good. Once again, before I leave, we will be having a quiz on Monday. That's why on Wednesday, we will be going over the study guide. So please make arrangements to attend that meeting at 2 o'clock on Wednesday. If you cannot make Wednesday at 2 o'clock, if for some reason you can make Wednesday at 1 o'clock, I'm doing period 1 during that. But otherwise, I could also, Thursday at 1 o'clock, I'm doing period 3. So any of those times that you can join, please join. Last thing, please do this assignment on a separate sheet of paper, unless you are very comfortable with writing this. But I think for most of you, this takes a lot of time to write this out, either on Docs or on Kami. So I would just do your work on a separate sheet of paper, take a picture, and attach it to the assignment on Google Classroom. Also, since you already have this in front of you, do the assignment right now. Don't wait until tomorrow when it's due. Do it right now, turn it in. Okay?
I already did it.
Cool. I know, Waldo was already working on it. He was already asking me about one of the questions there. If you have any other questions, please email me.